Hi, you're joining papaisniu, and we are back in this game called 7 Billion Humans. It's a parallel programming game. Okay, I am pretty much struggling at it because I suck at this kind of programming. Okay, but it's nevertheless still good practice. Okay, it doesn't mean that I'm bad at it. That means I don't give it a try, right? So, well, I will just keep trying my best and then stick around, okay, see how the progress goes. Hopefully it is something fun for you, okay, and maybe you will be able to learn something from my struggles, okay, or what's not. All right, injection sites number 1, year 11. There's a lot of 1 and I, okay. Wow, this tough. Important data cube from management, okay. Horizontal line, sure. Most of them anyway, sure. Zone out, sure. Fill in the missing data in each what? Just put those data cube wherever they fit. Order doesn't matter, right? Oh, 1 empty slot below each of you, okay. Horizontal line appear complete. I'm sure no one will complain, sure. So the idea is to move down and slot exactly where the emptiness should be. Alright. Sure. Optimization challenge 5. Wow. Really? 7. Wow. The speed challenge I can no longer understand because previously it's about number of steps inside human resource machine, but inside this game the seconds work a little bit different. Okay. Okay, nevertheless, let's get them to 5. You can do that. You can do that. I guess if I'm holding on to something, correct, I could so-called pick things up and actually don't end up picking it up, I guess. Okay, I should always step down. I should always step down. Then I should always pick up. Then if the left hand side is a data cube and the right hand side is a data cube, both left and right are data cube, I'm going to drop what I have. I'm going to drop what I have, which is bad. Which is bad. I actually don't want this. If the left is not a data cube or the right is not a data cube, I want to do this thing again. Left is not a data cube, right is not a data cube, okay, which is most situation, I should repeat the process of stepping and picking up. Only when this is not true, I'm actually done. On the spot, I'll drop it down, okay, so this actually saves number of steps based on how it's defined, because otherwise I'll have to use else, and that will be 6 steps, okay, so this actually save 1, this is 5 steps. Let's hope that works. Should always complain nothing to pick up, and nothing to pick up, and it should try to pick up when it couldn't. Yeah, it's already holding on to something nice. Something is already here. Oh, it doesn't work. It doesn't work. It doesn't work. It doesn't work. All the way outside. All the way outside. It should always attempt to drop. It should always attempt to drop. Okay, let's change. Now we change the ordering, try to keep within 5. So it should step down. And then let's say I already dropped. Okay, so let's say this lady already dropped the data cube here, but continue to stepping to here. Okay, she will attempt to pick up 71. But because left and right are both data cube, you'll immediately drop before stepping through again. Okay, so this should work. Let's try. Alright. Dengue, is that how to spell the name? Okay, we'll complain, sure, all the complaints. But it will try to drop the data cube. Okay, let's check out Penelope. Okay, then she will attempt to pick up 0 later. Okay, nothing, right? Okay, step down, attempt to pick up 0. But because left and right are data cube, you immediately drop. Alright, and then rise and shine. So this whole thing should work. Nice. Okay, that works. 5 or fewer commands. Why am I still doing optimization? Frankly, I should really ignore. Sometimes it's really hard, you know, like I just, you know, in my heart I was like, maybe just a short push and you'll be able to get it. So I still end up working on the optimization challenge. Alright, so speed challenge is obviously slow because of the way we set up. Correct, it's inefficient. It does a lot of error. Correct, the pickup error and all those, and there's a pickup drop where it shouldn't. Okay, so am I going to try to optimize for it? Why don't give me a brief minute or something? Okay, this is size. Let's write in size. Okay, do I want to do some speed challenge? Let's see. Oh, by the way, all levels on the left are harder levels. Okay, they are challenging levels. So this is one of the challenging level. Okay, what do I mean by level on the left? We'll see later. Okay, efficiency wise is hard code. Okay, step down, pick up bottom, don't need to step. So pick up first, then we will step down. If left is a data cube and right is a data cube and center don't have data cube, what I would do is to drop. Otherwise, I should jump. Okay, this is what I meant just now, that you actually take 6 steps if we set it up like this. Okay, you always pick up, then you always step, you always just do an initial pickup. Okay, and the step is actually loop. Okay, every time after you step, you check, is your right a data cube? Yes. Left data, both left and right are data cube? Yes. Center is not a data cube. This is the point that I'm going to drop and then exit the whole thing. Let's try. Nice. Okay, so that's done. Looks a little bit faster. Don't know how much faster that is. Okay, 10. Still a little bit over. Why a little bit over? Because else takes time? Because else takes time? Else doesn't take time. Else takes operation, but it doesn't take time. It is slightly over, right? It's slightly over. It should always take 2 steps. Correct? It should always take 2 steps. What I'm doing here is a little bit slow. Just a little bit slow, correct? 10 and 7, maybe about 50% slow. It could be done by saving loops, correct? So instead of one loop do this much, if one loop do twice as much, okay, that would be helpful. So every time I can take 2 steps, 1, 2, 1, 2, check, 1, 2, check, 1, 2, check, 1, 2, check. So steps can always be double steps, correct? That will save loops. Double step, double step, double step, go. Okay, let's check. 7 command, slow, nice, 7, yes. Speed challenge, achieve. Okay, that is pretty interesting. I have to say that if I manage to achieve it, then it's pretty fun to show on video, but otherwise it could really drag. Yeah. Alright, that was good luck. Okay, this is what I meant by the left path. Alright, all the right path is the original path that allows you to rise through the years. Okay, allow myself to rise through the years. Okay, and eventually graduate to letting the goodbye humans. Okay, from the robots. Okay, left path, they are usually harder problems. Alright, so I'm not going to dwell too much on the left path. Please don't dwell too much on the left path. Self-reminder, okay, it's hard, they're hard. Injection site number 2 is going to be seriously hard. Okay, I've saw a friend play this level before and it's crazy. Oops. Let's not panic. This time is a bit different. Okay, same thing, there are holes, but they are not directly below. Okay, and this is really bad. Miss a few spots. Sure. horizontal rows however you will like. And that this time is really hard, okay? Fill the data gap in each row. And the problem is I seriously don't know how to get them to the various locations, okay? There are some techniques, but each of them is seriously painful, okay? So for example, go to each row, then keep moving right, then go to the next one, remember that you should keep moving left, go to the next one, remember that you should keep moving right. So there are actually 2 sets of loops each time, okay? And that is still going to be pretty inefficient. Alright, so optimization challenge 10, you sure? Wow, and 55 is really time consuming. Alright, 10, wow, I don't know. I'm just going to solve it, okay, and see how. Step down. First thing, reach the conga line. Alright, reach the conga line. And then we are going to check, a big check, if the left hand side is a wall. If the left hand side is a wall, I want to keep going to the right. Else I want to keep going to the left. Let's do the other way around. If the right hand side is a wall, sorry, what am I doing? This either way isn't good. Either way isn't good. I'm going to quote the else case. Okay, this is for sure hitting the else. I'm for sure going to hit the else. If left hand side is a wall, I want to go right. Correct. It should be this way. It has to be this way because we are going to quote the else. Correct. If right hand side is a wall, so for example, when everyone move to the right, okay, and come down by 2 space, everyone is here, then we will want them to move to the left. Okay, so if right hand side is the wall, then we will step left. Correct. None of the empty queue is all the way at the edge, so we'll always step left. Alright, and then I want to check if where I'm standing on is not a data cube, drop it, and actually I'm done. Okay, then I should set it up the other way, right? Okay, jump. Okay, if where I'm on is a data cube, then I should step left again. But there is a worry. If where I'm standing on, if on the left is now a wall, then what do I want to do is to do the step down. Okay, if the left is a wall, I should step down by 2 again and check whether I'm on the left wall or the right wall. Okay, then when this is not true, I want to repeat the stepping. Okay, and then when I actually see the empty spot, I should just drop it, and then I am actually done. Alright, then what I'm going to do is to do the same for the other side, the else. Else side says that, well, I should always step to the right. Okay, so the first part will always be the else. Okay, we are stepping to the right, step to the right, and then I want to do the same checks. Oh, that's a bit inefficient. Okay, if what I'm standing on is a data cube, then if the opposite side is a wall, it's time to go all the way back to the top. Well, okay. Otherwise, if it's a data cube and not a wall, I should just continue moving. No else. Don't like the else. Okay, that will save us the else. Continue moving. And then otherwise, I should drop and end this thing. Check it out. Bad, 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 bad. All the way at the start, please pick up the data cube below you. And then step down 1, 2. What? That's bad. That's bad. Pick up. Step down. Oh, this is a waste of time. Okay, so what I'm going to do is to step down and pick up the data cube. After that, perform the step 2 down, conga line through the wall. Okay, let's check. Play. Pick up, okay, step down, conga line through. Do you see? Yes, nice, okay. Then everyone will move. Everyone will move. And then until the next empty spot. Alright, put down, and then so on. Alright, they'll automatically swap position if there's someone that's idle. Not sure whether that will take actually more time, but yeah. Slightly slower. Slightly slower. Okay, slightly slower. But okay, I think for this one, I'm not going to dwell too much on it. Okay, this is a very intuitive reference application. A lot of time in real life, that's what we do. Okay, we have a problem, we come up with the most intuitive solution. Okay, which is why it's very important to have good coding habit, coding skill, coding smell, understanding. Okay, all this thing. It's an art science. Because all this thing will help you to create a good reference code. Then we'll come back and decide whether how we want to optimize it, okay, within specific time constraints. So I'm not going to dwell on this thing. This is decent, okay. I can explain this code to people, okay, and there might be some small optimization here and there, but we're just going to leave it that way. Okay, and we are going to just leave it like that with none of the lights lit. Okay, I may come back to it later or what's not, and maybe not. Okay, alright, so if you enjoy the gameplay, do like the video so that more people can share, see them. Okay, comment below, see how it goes for you. Also, click the subscribe button, join me on more gaming fun in this game called 7 Billion Humans. Alright, so Papa is done, enjoy.